Have you ever wondered how large language models understand and generate human language? It's a fascinating journey of bits and bytes, patterns and probabilities. At their core, these models are all about understanding language, making sense of words and sentences, and even creating new ones. They're like a digital linguist, decoding the complexities of human communication. But how do they do this? To understand this, we must first dive into the transformer model, the backbone of these language models. At the heart of these large language models lies a brilliant piece of technology known as the transformer model. This model is the powerhouse behind the ability of these models to comprehend and produce human-like text. The transformer model comprises two main components, the encoder and the decoder. The encoder's role is to understand the input text. Also, it reads the text, breaks it down into smaller pieces, and then converts these pieces into a format that the model can understand. It's like a universal translator for language models. On the other hand, the decoder takes this processed information and turns it back into human-readable text. It's the storyteller, spinning the data into a narrative that we can understand. The interplay between these two components allows the transformer model to interpret and generate language, mirroring the complexity and nuance of human communication. With these two components, the transformer model can understand and generate language in a way that's remarkably similar to humans. But how exactly do these components come together to make sense of human language? Imagine the transformer model as an intricate dance between two partners, the encoder and the decoder. The encoder initiates the dance, leading the first steps. It takes in a sentence, let's say, "I love apple pie," and converts it into a series of numerical values. This sequence, a representation of our sentence, is what we call embedding. The encoder's job is to understand the context of each word to the others. Then it's the decoder's turn to take the stage. The decoder takes these numerical values and starts its interpretation. It uses the information from the encoder to predict the next word in the sentence. In our apple pie example, given the first two words, I love the decoder's task is to predict that the next word is apple. But here's the magic: the transformer model doesn't just stop at predicting the next word. It continually refines its predictions, factoring in each new word as it goes along. This process, known as attention, allows the model to focus on different parts of the sentence as it decodes, giving it a dynamic understanding of language. This dance between the encoder and decoder, this flow of information, is what makes the transformer model so effective in large language models.